So, hello guys. Thanks for the intro. This is going to be a very fast presentation. I know I have only 30 minutes. I have like 50 slides. So I'll rush. If anything doesn't work with you, just store it for later, please. Okay, so we're going to talk on how to build machine learning solutions on Google Cloud Platform. So it assumes that you have little or no skill on Google Cloud Platform, but that you know a little bit about ML. So that's why it's good that I'm coming a bit later today. Okay, so this is going to be the plan. We're going to introduce what's an ML solution, what is it involved, how do you do it on GCP, what are the different approaches, how to use pre-trained models, how to leverage AutoML, how to build custom solutions, and then where to go from there. Okay, so what's an ML solution? Basically, you have to understand that you use ML to make things easy, not hard. So it shouldn't be a thing that you do because it's difficult or that. It should be a thing that creates a solution. So come at it with that perspective, right? And yeah, so if you come at it from that perspective, what are the ways that we use it in real life? So most of our products here at Google are AI enabled. So for the past 10 years, we've incorporated ML in all of our products. So that's from search, from Gmail, photos, translate. All of these have features of machine learning that you may know, you may not notice. Things like, I hope you've seen Smart Reply. That's one we're very proud of now, where like you're in the middle of an email and Gmail kind of suggests things to complete your messages. Obviously, search is a lot of machine learning in the search ranking, speech recognition, and all that. So there's a bunch of like everything we do at Google incorporates a lot of ML models. And yeah, this is an example we're very proud of. I don't know if you're getting it there, but Google Translate is a great example of machine learning solutions that can leverage many ML capabilities, such as video intelligence, vision, translate NLP. So this is an example of you can just point your phone at a sign and it translates within the image. So what happens there? There's like vision, there's the vision getting there, there's video intelligence getting there. You have to see, recognize the sign, be able to transform the image in real time, translate the word, and within the same style. So there's so many models in this little example that works like in a snap. So we're very proud of this kind of thing where we kind of integrate all of that. But another example is just out of our products, even the way we run our business. So behind the scene, we use ML to like manage our data center. So what machines to turn on and off, when to turn on the heating and all that. And it helps us save energy. It helps us more efficiently use our resources in a way that, and that the learnings we get from that, we can share with other companies, with other industries, which need to better manage their resources. So things like cooling a data center, managing equipment such as pumps, chillers, cooling towers, and all that. So 2, what's involved when it comes to building an ML solution? So aside from developing the standard engineering beats of your product, what does it really mean to build an ML solution? So when we look at ML products, we identify 3 main phases. There's a discovery phase, a development phase, and a deployment phase. So for the discovery phase, you need to identify the business needs and its use case, and allows us to have a clear plan of a way for the model will help us to achieve. This phase is crucial because it will establish the problem that needs to be the task that needs to be solved, and how solving it will affect the business and the users consuming the product. So this phase is also when the data exploration happens, recognizing what data sets are needed, whether the needed data is readily available and sufficient to train the model, whether external data sets will be beneficial, how to acquire them. All of these are considerations that are involved in the data exploration set. Then, developing on the task, depending on the task to be performed, an algorithm is chosen by the data science team. The combination of data availability and algorithm, along with the decision of buying versus building a solution, all that becomes important considerations for feasibility assessments. So where the team tries to uncover any problems that may arise during the development phase. One example is that if for the specific use in case in question, the data is available historically, but not for inference time. In that case, the particular scenario might make the use case unfeasible for ML, and a more thorough analysis may have to be performed because the use case can be before it can be pursued further. So if you realize, for example, that data could be available in the past, but like at the moment we're trying to get it, it's not there. So a lot of assumptions need to be clarified at this stage. So another aspect of the discovery phase is prioritizing the different use cases that a business has at a potential ML projects, but that's not really in the scope here. So how does the development start during the exploration? Shouldn't we wait for until the results of the feasibility study and all that? But what happens is, in reality, that even for the data exploration and algorithm selection, some proofs and concept may be needed to be developed, and that's what we refer to here by development phase. So after the feasibility assessment gives the go ahead, the real development starts. All the data steps, such as cleaning, extracting, analyzing, transforming, will be implemented during the data pipeline creation. The data pipeline involves ensuring that all the operations needed in data for both offline and streaming will be performed consistently to avoid data skew. And after the data is ready, building and evaluating the model begins. And when we say it begins, is because these steps generally go through iterations. So there's many considerations to taking place. The use case should be revisited maybe because the learning algorithm is incapable of identifying patterns, for example, or data could be revisited because the model either needs more of it or needs additional features, for example, or some additional transformations are needed to improve the model quality. So there's this lot of iteration that happens. After the development phase, we go back into discovery and all that until we're satisfied. So when the results are presented to the stakeholders and they're satisfied with how the model is performing, it's time to plan for model deployment. So certain questions will arise. Which platform should host the model? Which service should I pick for model serving? How many nodes should the cluster have so they can scale on all that? So operationalizing and monitoring the model will avoid for maintainability, allow for maintainability and avoid like model decay. Like, just having the usability just kind of fall back. So that's what you have to do, and that's all in the deployment phase. Okay, so why would you build your solutions, your ML solutions from Google Cloud, GCP? So we provide a rock-solid foundation. You can rely on us. That helps you stop spending time, energy, and money on things that don't fundamentally differentiate your business. Again, I know that other big companies have ML platforms, so this is not an ad for Google, but in general, the idea of using an ML platform helps you use a solid foundation. Obviously, I would like that you consider Google's own, but that's up to you. Then we have a unique platform that allows you get more value to your data. You spend your time in your data rather than on your database, in the sense of just it's serverless. The compute data ML platform is contained, so you really focus on your data. And then we help you unleash your developers by giving them the tool to focus on what they do best, write code. So sometimes if you have a small company, especially like if you're a startup or if you're like in places which don't necessarily have a lot of startup funding, like in Cameroon, for example, if you're starting your business and you're trying to bring it to scale, it may be hard for you to have like, the amount of money needed to necessarily have a team of ML engineers building the models and all of that. And so it may be helpful for you to have a platform that takes care of all that. So you can just write the code and push the solutions. Okay, so basically, we're very proud of the fact that we're recognized as a leader by all the statistics and like all the awards for what we do. That's relevant for you necessarily. Now let's talk of the approaches for building ML solutions on GCP. So you have basically two choices when you want to take advantage of what we have. First, we've taken some of those amazing consumer services that and turn them into pre-built models with APIs. So you don't have to know anything at all about ML to build an app that can understand contents of images or videos or convert text to speech, translate between languages and all that. So that's one way. Or you can train your own models, take your own data and your own domain knowledge and build on and use the platform to build your own models. The two different ways to use it. So what are the tools to do these things? So Google Cloud has two ways for you to add ML to your apps. If you want to use your custom data to build and train your own models from scratch, then there's a Google Brain team has an open source library called TensorFlow, which I guess you know of. We have AI platform, which is a way to run TensorFlow in a managed service. It allows you to train TensorFlow models in a distributed way and just invoke predictions scalably without having to think about, all the underlying machine and everything. So that's on the left. On the right hand side, what you have is friendly machine learning, and that's what we really, see a lot of people adopting. So those are APIs that give you access to pre-trained ML models, and you just do an API call. So there's a variety of problems where Google exposes ML services trained with your own data. For example, if you want to transcribe speech, you could use the speech API instead of having to collect the data and train it and predict with it. So let's have an overview of these APIs and see how it works. So part 5, how to use a Google pre-trained ML model. Again, it doesn't have to be hard. So I know I've made my living as an AI engineer. I know we like to make it hard, but it doesn't have to be hard to use it to get some ML going. We can make it easy. So if you can invoke any of these pre-trained ML models for vision, for speech recognition, for translation, for video intelligence, for natural language, for dialogue. So let's have a look at the dialogue. In most cases, you want to create a chatbot, for example, using the Dialogflow console. So Dialogflow is an AI model pre-trained that we're exposing to you. And you may want to use a console like you see on the screen where you just say, hey, connect with this Facebook Messenger or Slack and this. So you connect it that way with a graphical user interface, and then you use your graphical user interface to tell you what to do. But let's look a little under, to see how it works. So basically, you have, it's designed with intents and entities. So intents are the meaning behind something that a user types or says to the chat box. So if a user says, are you open yet? For example, it's a chat box of your business. And the chat box replies, oh, we're open at 6. Basically what happened is like the intent there is get opening times, for example. So there's many different ways someone can ask a question and many different ways it can be answered. So what you would do when you're using our Dialogflow is that you would say, hey, there's this intent that I want you to take care of, which is called get opening times. And for someone who wants to do get opening times, he or she may say, what time are you open? Are you open yet? When do you open? You give a few examples like that. And then the ML engine would just generalize, oh, this is what someone can say to get to that intent. The ML engine understands what you want to do. And then you give it some sample responses. You could say, when we are open at 6, first sitting is at 6, not until 6. And then you give it like a schedule of what the computer can say. So when you say that once, the ML model is able to infer a lot and to be able to make full conversations based on the little examples you've given. So that's what you can do. So that's a very useful tool. Our businesses use it. So let me go to next. Oh, sorry, I think the slide repeats. Oh, sorry. So yeah, that was like basically an example or conversation. Sorry, it took me so many slides. Okay, so now let's look a little under the hood. Like I showed you how you use Dialogflow on the interface, but now let's look at the back end. So basically, all of Dialogflow's functionalities are available to the console, like the graphical console you saw. And the most common way to present the chatbot to the end user is through pre-built telephony or text integrations with applications like messenger applications. But sometimes you want to access your chatbot directly to an API. Like for example, you are building the next Facebook chat, like you're so you're an entrepreneur, you're building this chat app, and you want to use, some chatbot functionality. So you may not have like that point and click thing, but what you could use is direct API calls, right? So you can write code to interact with it, and this is how the structure would happen. So you send the user's message to Dialogflow by calling the detect intent. So you take the text, send it to Dialogflow, and say detect the intent on this thing, or string detect intent methods. And so the detect intent is used to get the intention, and then you could configure further by having Dialogflow listen for pauses in the audio. So you could actually, like, rather than taking the audio and send it to Dialogflow or text into audio, you can actually just have a stream. Like, your user is talking, and then you have a stream of audio, and then Dialogflow just listens to that stream of the users, in the phone call or something, and immediately the Dialogflow listens to a pause. It says, okay, the user has stopped something, and based on that sound that the user sent, it would like extract an intent and answer. So it makes it look like a natural human conversation. Like, the machine is listening, breaks it down into sentences, extract intents, gets replies, send it to text to speech, and answer. So you can have that level of conversation, which looks very natural in your apps, just by calling the API. So that's what we're trying to do, like make it easy so you don't have to like necessarily build the APIs yourself. Okay, so this is just another way to deploy it, like how, because the previous slide was more about, the conceptual blocks. This is how you would deploy it into microservices, which are served on the Google ecosystem. So this is an example of how you would invoke a pre-trained ML. So right there, for example, this is someone using the translate API, and he'll basically be like, okay, I want to translate. I'm starting a function called translate to French. I basically import the translate model. I can instantiate a client. I send the text. I send the French, and I do it, and I get a reply. So this is basically how easy it would be if you want to use this approach of using pre-trained models. It's just calling functions, no model to create. Okay, so this is an example of I know the internet is not good, so I'm not gonna stream, but this is a YouTube video. I think it's available on public YouTube, so you could just search it on YouTube. Basically, where Bloomberg is like the biggest source of financial news. So they serve all the financial markets around the world. They serve all the newspapers that with all the financial analysis and all that. And this video is where they explain why they just had to start using Google Translate, because you can't have editors in every language, if you want to do breaking news and you have massive amounts of text going through, you need to automate a lot of that and then have humans just check. So that's basically what they're going to explain to you, how it makes sense business-wise and effectively, and how it's cheaper to just use pre-trained models. So that's basically the content of the video, which I will not scream for internet reasons, I guess, but you can find it by searching it online. And there's many examples of successful, deployments of Google models. Okay, so how do you leverage auto? Oh, wait a minute. Okay, cool. It's I was waiting for it to change. Cool. So part 6, how do you leverage AutoML for building your solution? So in case you don't want to use pre-trained models, you want to use AutoML. It's another way to do it. Let's think about it. So why Cloud AutoML? So AutoML is a suite of products to enable cloud deployment strategies with limited ML expertise, but build high quality with an easy to use UX. So basically, we're trying to like hold your hand, help you build ML solutions by yourself, but with a UI and which is easy to do, where you don't have to like, be writing in notebooks and writing the code all by yourself. So that's what AutoML is. So if you don't want to use the pre-trained models that we have, you want to create your own, but you want like an environment that makes it easy, you come to AutoML. So you can be a citizen data scientist or developer. You want a custom model, you want it to be simple, and you want high quality, come to us. Good. So basically that's it. So we would want a situation where you can just pick your data set and using a graphical interface, just upload it and then click a button, it trains the model, and then boom, it gives you an API where you can do your predictions. So what we're trying to do. And that's a product you can use. So for example, AutoML Vision was the first project. Uh, so and the first AutoML product we launched was AutoML Vision. So it helps customers automate image classification scenarios. For example, let's say you're a retailer, right? Trying to categorize, automate the categorization of your products. All you have to do is feed examples of handbags, shoes, hats. Just feed examples. This is a handbag. This is a shoe. AutoML just automatically does the magic behind the scenes and produces a model, so you can use to tag the rest of your catalog, all without having to deal with model quality and UX and all that. So you just have this interface. You upload photo, handbag, photo. You tag them, and it trains the model. And then as from then on, it just like gives you the answers by itself. So you can also automatically build state-of-the-art models, including feature engineering, model architecture, selection, tuning, etc. with one click. You can enrich text across a wide range of domains. You can automatically predict text categories through either single or multi-label classification. You can navigate a codeless graphical UI through full ML lifecycle. So like you don't write code, just a UI. You can take advantage of the online prediction APIs, and you can actually even export your model to other platforms. So this is like an example of using AutoML NLP, where you have like different label text, and then you can recognize what a piece of text is about after training it for a while. AutoML translation, that's another very interesting use case where you can customize the generic Google neural machine translation model. So you can improve the quality of machine translation for your particular use case. So what you would do is upload your data and train and test your models using simple UI APIs. So you don't need to write any program. You would just go to a user interface, like a web interface, and just upload examples. This means this means this means that. So it will build on the translation model we already have and specialize it for your use case. You can just use it like that. AutoML recommendations is another situation where you give it on, you upload just labeled structured data, you train it, and then it's able to give recommendations based on it. Or you can use AutoML tables. So you give it labeled structured data, and when you train it, it's able to like classify the different lines of your table, for example. You can classify and make some groupings and all that. So there's a lot of things you can do by just having data, inputting it into AutoML, and it gives you some useful results. So let's say you don't want to use the pre-trained models. You don't want to use AutoML to just have a graphical user interface where you can click and drop the thing, and you want to build your own solution. That's also possible. So how do you build a custom ML solution? Basically, Google also offers tools such as TensorFlow and Cloud ML, so you can create models of your own. You have your input layers, hidden layers, and all the out layers. You can do all of that. So focusing on the development and deployment phase, we see that they have multiple steps. So for data exploration, for example, there's data extraction, data analysis, data preparation. The model building comprises training, evaluation, and validation. Deployment requires hosting the trained model and serving it and having a prediction service ready to handle requests, and then the monitoring to allow for continuous evaluation and training based on performance and at any given point. So to do all of that, we have tools that we allow you to do like all these different phases using Google infrastructure. So we're looking at this in more detail maybe later, but first let's look at the TensorFlow extended platform, right? So because all these other tools, like when you think of machine learning, you're really thinking of the training part and all that. So let's look at the TensorFlow platform, where you do like training your model and all that. So basically, this is an example of someone who would use our TensorFlow platform and the different services they would deploy for that. So the ML engine is just a part of all these solutions, right? But all of these steps you can do with our solutions. So you take in your data in different forms. You would ingest it either with transfer service, which allows you to pulling huge amounts of data, or PubSub, which allows you to do real-time publishing and publishing of data. It's almost like a stream of continuous information. You could use that as well. Then you would pre-process using Dataproc or Dataflow, and then you would store it either in storage and use BigQuery, which is like a kind of like an SQL, but for huge data sets, and then store it in Bigtable. And then you would experiment with Data Lab and visualization and get visualization insights, or you would train your models using AI platform, which contains TensorFlow and all that, and then that will pipe it into any applications you have, or you could just build reports with Data Studio and all that. So all those tools, they allow you to have a more hands-on, because in each of those tools, you can actually go manually and do the modifications you want to do if you want it to be exactly like you want. So this is an architecture for real-time and batch ML solutions. I'm not sure if it's relevant to the level in this, but this is just an example of how you would structure your ML model if you were like more of building your own. And a practical example of how you could have that pipeline from input events and all the way through your model and all the way to output. So this is more like an example. You could structure your own differently. So the cloud AI platform, while AI building blocks can address the majority of your machine learning use cases, depending upon the type of data and the level of customization, we have an advanced platform for users who want to build custom machine learning models from the ground up. So our goal is to deliver the fastest and most flexible platform that's agnostic of framework, infrastructure, and preferred tool chain. So you could use a cloud AI platform to build your models and then host them. Like if you don't want to use all the services that I talked about, which kind of like pipe the data from input to model to all that, you can literally just run a rig, like a virtual machine, which is specialized for that and which contains TensorFlow. So this goes like even lower than that. So the Vertex AI Workbench is what we use to kind of visualize the data streams in all of a machine learning project. I think this should be out of the scope of this conversation. So let me not get deep into this. So basically, this is just like the UI interface you would use to deploy your models on our cloud AI platform. So you can have the jobs be run distributedly. You can just use an interface to run up servers. You can do a lot of customization of your model directly in the Vertex AI environment. Kubernetes, Kubeflow pipelines, to realize the buildings of applications that can run anywhere. We have a complete workbench to compose this end-of-end machine learning pipelines. And Kubeflow pipelines is one of those tools. So you can easily launch hundreds of different variants of your machine learning pipelines to experiment with them. So this is more meta. Like if I already have my models and all that, and I want to experiment, I want to have different pipelines which work from sources from different places. So that's after I've done the machine learning part, and I want to do more of the operational side, deploying different models at different places and running A/B tests and all that. I would use the Kubeflow pipelines. AI Hub is another tool you can use to discover plug and play pipelines by others. So rather than building your own pipelines and all that, you could just like download kind of a pipeline that's been pre-designed using AI Hub. So that's a place where you can share other pipelines with other people, if that makes sense. So using AI Hub plus Kubeflow pipelines is I would get ML pipelines, which have been pre-designed either by my team or other people. I will deploy them in my Kubeflow, and it will allow me to have desired pipelines for my models. So that's more meta, maybe a bit above the level of this conversation. But let's have a recap. We're 28 minutes. I know I'm heading for 30 minutes, so I hope I'm not boring you. This is the recap. We're almost done. So the recap is, this is the list of all we have as products you can use to build your AI models. So I don't know if you want to take a screenshot of these. I don't know if it's relevant, but these are going from the cloud AI, the managed models, the pipelines and all that. These are the different things you can use to build your AI tools and your AI models on the Google infrastructure. So what's the way forward? Well, you can try it out today on cloud.google.com. You can build something very easily and publish it. And you can, for free, for nearly free, I guess, if you're just paying a membership or something like that. You can get certified, actually. It's very cheap. As a cloud engineer, as a cloud architect, as a data engineer, as an ML engineer online. You can, if you want to take those courses, you can do it, and you can learn how to do all of that online. So that's the way forward if you're interested in all we talked about. And I am so very thankful for your time. And please, 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 please ask me any questions. Why do I have all these icons here? Well, let me get back to here. You can ask me any questions, so you can shoot me an email at my email down there. Thank you for your attention. It's been 30 minutes. I give back. I'm listening for any questions you have.